Hello everyone, welcome back to my channel. Today we are going to do our continuation of our previous class. We had done till question number 3 of exercise 1.2 of the chapter real numbers, and today let's move on to our question number 4, and that is given HCF of 306 and 657 is equal to 9, then find the LCM of 306 and 657. How do we do that? We had discussed a formula in the last class, which was if two numbers A and B are given, then the product of two numbers is equal to LCM of A and B into HCF of A and B. Now from here, how can you get the LCM? So let's write in that form. LCM of A and B is equal to the product A into B by HCF of A and B. Now let's substitute the values. What is A and B? That is 306 into 657 by 9. Now 306 and 9, when you cancel, what do you get? You get 34 into 657, which is equal to 22,338. So this is the answer. Now let's move on to our next question, which is question number 5. Now this is our fifth question. To check whether 6 raised to n can end with the digit 0 for any natural number n. So for the number 6 raised to end with 0, surely it should be divisible by 5. So if 6 raised to n ends with 0, then it will be divisible by 5. So now let us check the prime factorization of 6 raised to n to see whether 5 is a prime factor. So how can you write 6 raised to n as? You can write it as 2 into 3 raised to n, which can be written as 2 raised to n into 3 raised to n. But by the fundamental theorem of arithmetic, what can you say? According to its uniqueness, there are no other prime factors other than 2 and 3 for 6. So clearly you can say that 6 raised to n cannot have 5 as a prime factor, and so 6 raised to n does not end with 0. So how do you write? By the uniqueness of fundamental theorem of arithmetic, there are no other factors for 6 raised to n. Therefore, 6 raised to n does not end with 0. So this is what we have proved. For any number n, 6 raised to n cannot end with 0. So now let's move on to our next question, which is 6. So this is our 6th question, which is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So let us take the first part. So first part, it is 7 into 11 into 13 plus 13. We need to show why we can write this as a composite number. So let us take this first part, 7 into 11 into 13. How can I write 7 into 11? We get it as 77 into 13 plus 13. Now from here we can take 13 common. So what do I get? 77 plus 1 into 13. What is 77 plus 1? It is 78 into 13. 13 is already prime. So let's try splitting this 78 as a product of primes. So let us do the prime factorization of 78, which is 2 39s are, again 3 13s are. So how can you write 78? You can write it as 2 into 3 into 13 into 13, which is equal to 2 into 3 into 13 square. So now we can finally represent this given number as the product of primes. So we can say this is a composite number. Since 7 into 11 into 13 plus 13 can be represented as product of primes, it is a composite number. Very easy, isn't it? Now let's move on to part 2. Now this is our part 2, which is you need to explain why the 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. So how do we do? Here you have 5. So let us keep this 5 as such and let us multiply the remaining and write what do we get? 7 6 are 42 into 5 into 4 3s are 12, 12 2s are 24, 24 1s are 24. So 24 plus 5. Now what is 42 into 24? 1008 into 5 plus 5. From here we can take 5 common. So what do we get? 1008 plus 1 into 5, which is 1009 into 5. Now 1009 is already a prime, 5 is also a prime. Since this given number can be represented as the product of primes, we can say that the given number is a composite number. So since the given number can be represented as product of primes, it is a composite number. Hence proved. So now let's move on to our next question, which is question number 7. So this is the 7th question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and all the same time and go in the same direction. Then after how many minutes will they meet again at the starting point? So to find out at how many minutes will they meet at the starting point, what should you do? You need to find out the least common multiple of Sonia and Ravi. So let us find out the LCM of 18 and 12. So first let us prime factorize the 18, which is 2 9s are, 3 3s are. So 18 you can write it as 2 into 3 square. Now next let us find out the prime factorization of 12, which is 2 6 are, 2 3s are. So how can you write 12 as 2 into 2 into 3, which is 2 square into 3. Therefore, LCM of 18 and 12 is equal to 3 square into 2 square. So that is 3 square into 2 square, which is 9 into 4, which is 36. Therefore, at 36 minutes, Sonia and Ravi will meet again at the starting point. So that was our answer, and that's all for today's class. The next class, we'll start with our next exercise, which is exercise 1.3. So till then,